Hello everyone. In this video we are going to solve the following system of equations and find the all real solutions of x and y. So here x and y belong to real numbers. Let's start. First of all, let me rearrange each equation as follow. So here in the first equation I can express as x squared plus 2xy plus y squared minus 2xy is equal to 4. And in the second equation we see that this equation is factorable, so I can factor it using the following formula. So we know that a cubed plus b cubed is always equal to a plus b times a squared minus ab plus b squared. So therefore I can easily factor the second equation. So x plus y times x squared minus xy plus y squared is equal to 8. And we see that this three terms is the perfect square. So using the following formula I can express the perfect square. So we know that a squared plus 2ab plus b squared is always equal to a plus b to the power of 2. So therefore this equation is equivalent to, in the first equation we will get x plus y to the power of 2 minus 2xy is equal to 4, and the second equation is x plus y times, so I can here also get perfect square. So first of all I have to express as follow: x squared plus 2xy plus y squared, and as you can see, to get minus xy I have to subtract 3xy. So this one is equal to 8. So therefore the final one is x plus y to the power of 2 minus 2xy is equal to 4, and here x plus y times x plus y to the power of 2 minus 3xy is equal to 8. So now here let's set that x plus y is equal to m and xy is equal to n. So therefore this is gonna be m squared, and so this is gonna be 2n, and this is gonna be m, this is gonna be m squared, and this is gonna be 3n. So therefore I'll get new system of equation with new variables here. So m squared minus 2n is equal to 4, and m times m squared minus 3n is equal to 8. So let me label each equation. This is the first, this is the second, and from the first equation if I solve for n, so let me rewrite the first equation here: m squared minus 2n is equal to 4. So let's move this 2n to the right hand side and 4 to the left hand side. So I'll get 2n is equal to m squared minus 4, and here n is equal to m squared minus 4 divided by 2. So now if I substitute into n into the second equation m squared minus 4, so therefore from this equation I will get m times m squared minus 3 times m squared minus 4 divided by 2, and this one is equal to 8. So now I can now first of all simplify inside of the bracket. So m times m squared 2, so here the common denominator is 2, so here 2, and this is gonna be 2m squared minus, so if I expand this I'll get 3m squared, and minus 3 times minus 4 is plus 12 is equal to 8. So therefore this is gonna be equivalent to m times, so we see that 2m squared minus 3m squared give us minus m squared, so therefore 12 minus m squared divided by 2 is equal to 8. So here the common denominator is 2, so therefore here 2, and this is gonna be equivalent to m times 12 minus m squared is equal to 16. So now let me expand the left hand side of the last equation. So 12m minus m cubed is equal to 16. So therefore if I move all terms to the right hand side, then I will get m cubed minus 12m and plus 16 is equal to 0. So as you can see, here we have cubic equation. So as we know, there is no specific formulas to find the roots of the cubic equation, so therefore we have to try to factor it. So therefore I can split now minus 12m as follow: m cubed minus 4m, so let me group like this, and minus here 8m and minus 16. This is going to be equal to 0. So now, from the first bracket, if I factor out m, then I can have m times here m squared minus 4. And from the second bracket, I can factor out 8, so to have m minus 2. So this gonna be equal to 0, and we see that m squared minus 4 is factorable by using the following formula. A squared minus b squared is always equal to a minus b times a plus b. So therefore, I will get from the last equation m times, so here since 4 is 2 squared, so therefore m squared m minus 2 times m plus 2, and minus 8 times m minus 2 is equal to 0. So we see that here we have a common factor, so therefore I can factor out here m minus 2. So in the second bracket I can have m times m, so m plus 2 and minus 8 is equal to 2. So this product is equal to 0, so therefore I can equate each expression to 0. So m minus 2 is equal to 0, and here m times m plus 2 minus 8 is equal to 0. So here we will get immediately m is equal to 2. So as you remember, we already solved for n. So n was m squared minus 4 divided by 2. So let me write here. So we know that n is equal to m squared minus 4 divided by 2. So therefore, plugging into m, I'll get n is equal to 2 squared minus 4 divided by 2, which is equal to 0. So here I'll get first set of solution, mn belong to 2 and 0. So for the second equation, let me expand this product. M squared plus 2m minus 8 is equal to 0. And we see that this is the quadratic equation. I can use discriminant to find the root. So m1 and 2 is equal to minus 2 plus minus 4 plus 32 divided by 2, and which is equal to minus 2 plus minus. And we see that this is going to be square root of 36. From that, I'll get 6 divided by 2. And here, m1 is equal to, if we take with plus, then minus 2 plus 6 is 4. 4 divided by 2 is 2. And m2 is equal to, if we take with minus, then minus 2 minus 6 is minus 8 divided by 2 is minus 4. So, therefore, we already found that if m is equal to 2, then n is equal to 0. So here I can immediately get n is equal to 0. And for this one, is m is equal to minus 4, then let me again write for n, n is equal to m squared minus 4 divided by 2. So therefore, plugging into m minus 4, I will get the solution for n, minus 4 squared minus 4. This is going to be divided by 2, and this is equal to 16 minus 4 is 12, and 12 divided by 2 is 6. So here I'll get another set of solution, mn belong to, so here minus 4 and 6. So now, as you remember, x plus y was n, m, and xy was n. So now let's plug into mn these two set of solutions. So here I'll get two system of equations. The first one is x plus y is equal to, we know that 2 and 0, so therefore this is going to be 2, and xy is equal to 0. So here let's solve immediately, and we can use to solve easily this system of equations Weie theorem. So assuming that x plus x and y are the roots of the quadratic equations, so here roots, so therefore I will get the quadratic equation as t squared minus 2t and plus 0 is equal to 0. So this is going to be equivalent to t squared minus 2t is equal to 0. So here I can factor out t, and therefore t minus 2 is equal to 0, and the product is equal to 0, so therefore I can equate each expression to 0. T is equal to 0 and t minus 2 is equal to 0. Here t is equal to 2. So therefore the solutions are x is equal to 2 and y is equal to 0. This is the first set of solutions, and the second set of solutions, y is equal to 2 and x is equal to 0. So now the second system of equations is x plus y is equal to, we see that m is equal to minus 4 and xy is equal to 6. So therefore here again, assuming that xy are the roots of the quadratic equation, I will get the following quadratic equation: t squared, so plus 4t and plus 6 is equal to 0. And here, okay, let's try to find the roots. Minus 4 plus minus 16 minus 24 divided by 2. And we see that the discriminant is negative. So therefore, there is no real solutions. So let's finalize. If we finalize, then I will get two set of solutions. So xy are first 2, 0 and 0, 2. So this is our final answer. Thank you for watching. Please comment and subscribe to my YouTube channel.